Okay, there we have see some frequency from output, but this is working. Really, do you interest an inverter? This is logical inverter you are made at your home. This kinds of inverter has one thing, this can oscillate. I am using this oscillator. No, this is not oscillator, this is a relay. This relay can operate at 12 volt and 5 volt to 12 volt essentially. Not necessarily this is 12 volt or 5 volt, because of my transformer's load is so down, because this is 600 milliampere only. This kinds of transformer hasn't to make a big appliance for preferable. This is a 5 watt appliance. I'm gonna test for this video. This appliance is working or not. This is also HB side and this is HT side. This is my power source. Now I'm oscillating from this relay. This can oscillate the plus point this from this and the negative from this white wire. This is the tapping wire for this coil. That's for I'm saying this is 2 winding coil for secondary. This is mid and this is last and this is fast. Question for all, these kinds of inverter does not produce sinusoidal signal. It is produce a square wave signal. That's for I am preferred. This is not used for any appliance. This can harm for your appliance, because of your appliance is working at 220 sinusoidal source, pure sine wave or essentially around that. Hello viewers, this is Tanbir. You are see Techmaster BD. If you not subscribe my channel, you can subscribe and share with your friends. There are more interesting video you can find. Also you can support me on Facebook page and Instagram. The link is the video description below. Please press the bell icon button. Let's move on the main video section. This video is basics of logical inverter. This is the example for DC to AC converting system. I'm using these kinds of transformer. You will see this video as a 600 milliampere. This is very small transformer at controlling 12 volt. Generally use this transformer our minimum appliance in our home. Likely this red wire is high voltage side. This is providable as a 220 volt, and there are secondary side. This is the coil first round to this is last round, and this is mid tapping coil. All over this is 2 winding coil, we are also said, but this is secondary coil providing 12 volt. Now we are reversing this method. We are using the AC 12 volt this side and output 220 volt take here, because of directly is the DC voltage is not working on this coil, because of the electromagnetic induction doesn't prefer DC voltage to make induction. That's why we need a oscillator circuit to make oscillation for this 3 wire and to oscillate this coil to make magnetomotive force. And we also know magnetomotive force is proportional to electromagnetic force. That's why there has providing 220 volt electromotive force. So let's make the main circuit. How to make a oscillator circuit using one relay. You are also see this is 12 volt DC and 220 volt VAC relay. This can oscillate a secondary coil side of my transformer. So better view, I am use the another one relay switch. This can also postmortem of a relay. So how it look like internal side. So viewers, this is slightly internal side. This relay has a common pin which is provided this side. I'm take a wire from this. This is my broken pin. That's why I'm wiring from this. So this is common side and this is normally closed side NC, and this is normally open side. Potentially it is simple to learn to make an inverter. It is very simple to connect my wiring diagram. At first you have to take a one wire. This is my relay coil side and this is my normally closed side, and this can connect each other. Okay, my wire is connected, and also this black 2 wire is coils first and last side. This from middle tap side. That's why this 2 wire is first wind and this 2 wire is second wind. I'm preferring this is the negative side of my voltage source, and I'm make oscillation for positive side from my voltage source for this 2 wire. In the meantime, pretty fast to oscillate this wire to continue positive side. So in the meantime, these can oscillate each other. That's why there are electromotive force and created, and this can provide MMF also, and MMF produced electromagnetic force for this HV side. So this is my normally closed side and this is normally open side, and I'm connecting the black two wire, this and this side, and the white wire, the middle of the coil, is connected with my negative side of my voltage source with relay coil negative side, and the middle pin is connected with positive side of my voltage source. So my all connection is done. Take two wire to connect my source side, one from this negative side and one from the common side of my relay. This from common side I'm making physically from this. So there I'm providing positive side is continue to at least my common side and negative pin as a red wire. For connecting my voltage source, I'm use a one breadboard to connect my voltage source side for my power supply. As I'm talked, the positive side is connected with my white wire and negative side is connected with my red wire. This is connected. Let's test the circuit to start my power supply as a set of 5 volt and 12 volt. So my HV side is connected with my appliance directly. I'm soldered. This is 5 watt LED. So let's see what happens next to it is working or not. Before start my power supply, I can say one thing. This relay, when oscillating, this can produce very peaky sound. This is very humming, and for experimental purpose, this is not matter on my appliance and essential performance. That sound creating on my relay physical switch from this magnet. Okay, I'm starting my power supply. Okay, there we have see some frequency from output, but this is working. For the output, I'm reached ratings from my multimeter. Let's test the multimeter readings. Okay, it can produce 147 volt around AC. Also this circuit is operating at 5 volt. Now let's make the increasing my voltage source to what happened next to see. Now I am creating a 10 volt my voltage source. This light intensity is very, now it increasing from previous. Now take a ratings. Okay, now it is 196 volt. Let's make 12 volt from my voltage source. Okay, now it is 12 volt. So it is almost 195 volt. Now I am making 14 volt voltage 14 volt of my voltage source to see it is working or not. Okay, my frequency is slightly down. This is not supported. Let's decrease my voltage source. Now it is slightly 12 volt, 12.5 volt. I am set my voltage source to see what happens next on my output. Okay, this is 182 volt. Okay, it is 195 volt for 11 volt. $197 volt for 10.4 volt. 189 volt for 8.5 volt DC. Now it's 6 volt. What I want to see, my output. Now it is almost 1.5 volt, 150 volt. But my appliance is also working, but I'm not creating my connection at big appliance or expensive appliance, because of this type of inverter is slightly logical but not professional. This is example and basics video how it works and what is the main criteria to make an inverter at our home. This is not preferable for our big or expensive appliance, because of these kinds of circuit can produce a square wave signal, but our regular appliance is working at sinusoidal signal also 220 volt. This can slightly produce voltage AC signal also, but this is not okay for our appliance. But this is the main criteria to make inverter. This is the basics also. Next video I will show you how to make wireless charging system to use this oscillator. No more today. See you in the next video. Thanks for watching.